Okay, everyone, welcome to this week. It is October 19th, and today we're not really starting the new 9 weeks. Technically, it started last Thursday, but we only had one day of it last week, so we're going to say that this is the new 9 weeks. I want to talk to you guys a little bit about your grades. I want to talk to you a little bit about the notebooks, and I want to talk to you about the first assignment in the second 9 weeks. First thing I'm going to start with is your grades. They'll be finalized here shortly in about an hour based on my clock. And yeah, that's it. I made a decision. Well, let me back up a little bit. We were told last Friday to lock down first quarter and be done with it. And so I made a decision that I'm going to let you guys make up a few things from there even after the 9 weeks is over, because I want to help some of you get your grades up. This isn't going to be everything. These are going to be specific things, okay? And all they're going to be are the notebook and the last activity. The last activity was on physical evidence. I'm going to let you make that up and the notebook up. And the notebook gets submitted here, but it was a major part of some of your grades, and several of you would do very well, would improve your grade quite a bit if you were to hand in the notebook. So if you want, you can go back, complete the notebook, and in fact I'm going to share with you a folder that has all of the notes in it. I'm going to share that with you, and I'm going to unlock just the tutorials inside of Edmentum or Plato, whatever you guys want to call it. I'm going to unlock just the tutorials, and I'm going to do the notebook. And if you want to complete a notebook and submit it here where it says October notebook check, that's going to be the only way that I'll accept your notebook, and then I'll put it in as a grade change. I'll also unlock the activity, the last activity on enzymes, and I'm going to give several of you guys a shot at redoing that or completing that. Most of you guys did it, just a few of you could use a little help. Those are the two things I think would really bring a lot of your grades up. If you do that pretty quickly, you'll see your grade go up pretty soon. It's important to have that first 9 weeks grade up. You can watch my last video and talk about that. Listen, we're going to be doing another notebook check right around Thanksgiving. There's going to be a folder here that says October stuff. All the October stuff's going to go in there. Then there's going to be new things. There's going to be a November calendar and a November notebook check. Okay, it's got to go here. I don't want you guys emailing it to me anymore because you claim to not be able to figure it out. This is where it's got to go. I will no longer accept emailed notebooks. They must go here. And although I think I only let one of you guys do this, I want to be very clear about something. As of now, I will no longer let anybody give me a digital notebook. Notebooks have to be pulled down, printed out. These notebook pages have to be pulled down and printed out, filled out with your hand, pencil or a pen. Then you take a picture, take a video, or you can scan it, and then you submit it here. Now, we've had 9 weeks to know how to do this, and so if you haven't figured out how to get a printer by now, that was a requirement before school started. If you haven't figured out how to print or where to print, I apologize, and I don't mean to sound cold and heartless, but that's something you're going to have to deal with. They must be printed out, they must be handwritten, they must be then placed here. Okay? Alright, enough of my griping. I'm actually going to go into the calendar now, and we're going to talk about this week's work. Today is October 19th. So we're going to make the screen bigger, and we're going to scroll down here to October 19th. And as you can see, I am going to put a few things in here, some links to just some videos I want you guys to read about toxicology. But for the most part, you're doing the tutorial on toxicology. I have the guided notes. Don't know why they're not linked. I'll get those linked very shortly. And then there's the mastery test. And we're going to get all that done this week. And I'm going to go ahead and go into the toxicology tutorial right now. Toxicology is, you can see the root word there is toxic, and then ology means a study of, so we're going to be looking at the study of chemicals, poisons specifically, although we do classify drugs as poisons. So toxicology really looks at mostly chemicals that are found in the blood. The objective right now is you will describe laboratory procedures for analyzing substances such as alcohol and drugs. So we're going to skip past all this. I'm going to make it bigger. Yep, boom, 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 boom. Okay. In this lesson, you'll explain how alcohol is processed by the body and identify the procedures used to determine blood alcohol levels. Okay. So we're going to start talking about alcohol. Then we're also going to talk about guidelines for preserving blood samples in a forensic laboratory. You find a person injured or dead, and you draw blood. And there's two kinds of blood. There's blood comes from before you died, and blood comes from after you die. Finally, we're going to identify controlled substances found at a crime scene using appropriate lab procedures. And when I say controlled substances, I mostly mean drugs. All right. Skip that. Okay, alcohol. Yes, that alcohol. We're going to be talking about what we call drinking alcohol. Before I go too far, I want to tell you there are two main types of alcohols. There is what we call drinking alcohol, or ethyl alcohol. It is distilled grain spirits. We get it from taking grains such as wheat, corn, barley. We can also make it out of potatoes, just about any fruit body or any plant body, except for the stems and the leaves. But we can take these things and we can turn them into a drinking alcohol. And if not abused, alcohol is rather flavorful. There are people who enjoy the effects of it. It goes great with certain foods. And as you know, as Christian as I am, I see no problem with the occasional glass of wine, the occasional cocktail with a meal. I think it's actually quite tasty and pleasurable. But too many people abuse it, and alcohol abuse is very common. It's one of the most common things going on in our world today in terms of drug abuse. Alcohol is a drug. It is responsible for almost 50% of all deaths in automobile accidents. Quick statistic. People between ages 16 and 24, 50% of deaths in that age group are caused by automobile accidents. I'm sorry, that's not true. The leading cause of death in that age group is an automobile accident, 50% of which involve alcohol. It causes euphoria, which is what everybody's going for, this euphoric feeling. You know, you feel, I guess the common word is feel high. It makes you drowsy, but it also can start affecting your neural system, which slurs your speech, impairs your judgment, causes your reactions to happen more slowly, which is why, as a result, you shouldn't be driving a car. Stupid. Prolonged consumption of alcohol, people who are drink all day, or drink not all day, but drink every day, can cause liver disease, nerve damage, and cancer. Our body cannot store alcohol, so what happens is our metabolism, especially our liver, starts removing the alcohol from the blood and eliminating it. And the more you drink, the more goes into your blood. We don't have an ability to just temporarily store it somewhere and release it later like we do with other things. And you, of course, can drink to the point where you are dead. Alcohol poisoning is common. It happens. I have known people that has happened to, and it most often leads in death. Alcohol is water soluble, so we don't have to digest it. What can happen is it's a very small molecule too, so it just goes straight in, starting with the stomach, actually starting with the esophagus. And it's not so much in the mouth, but even in the esophagus and definitely in the stomach, alcohol starts going into the bloodstream. When it gets to the small intestine is has such a huge surface area that it absorbs the alcohol very rapidly. It also depends on things like body weight. Heavy people can drink a little bit more than light people because they're just bigger people, so they have more blood. Gender, males tend to be larger than females, so males can tend to drink a little bit more than females. Certain ethnicities or races are slightly less susceptible to the effects of alcohol, just slightly. Okay, it's hardly even measurable, but it is there. And then one of the big things is, have you eaten? If you eat, or if you consume alcohol on an empty stomach, it's going to go into your bloodstream faster and impair you quicker. It'll also be eliminated faster, but having a cocktail with a meal more than likely will have little to no effect on you, whereas having a cocktail without a meal is going to make you become inebriated much more quickly. After the alcohol is absorbed, it quickly goes through all of your body, It's a small molecule, like I said, so it goes to every organ. Because it's water soluble, it goes to every organ. Your brain is particularly susceptible because it's the blood, it gets most of the blood in your body. And so as a result, you can become impaired very quickly. About 90 to 98% of the alcohol is eliminated by the liver, which that's then turned into something called acetaldehyde and acetic acid, which is then eliminated to the urine. About 2 to 10% of it is eliminated through sweat, urine, and saliva. Some of it's exhaled out of the lungs, but hardly any of it's worth worrying about. But this is all important so that you know how we can find out at a crime scene how intoxicated a person is, how long ago they were drinking. Even a dead person, you can measure the amount of alcohol in their blood. Even though a very little amount of alcohol comes out in the breath, you can measure that, and that is a breathalyzer is one of the main ways that cops can determine your blood alcohol level, and it is admissible in court because it's a fairly common technology. Back to this, if you have, I want to go back one, or actually one more. Well, hold on a second. Sorry, I don't know where it says it, so I'll just keep going. But you only have to have a 0.8%. That's less than 1% of your blood alcohol volume. If it has alcohol in it, you're considered intoxicated to the point of being legally drunk, which means you can't drive a car. Okay, so let's talk about those effects. The short-term effects of heavy drinking in a single occasion can lead to nausea, vomiting, and unconsciousness. Alcohol mainly affects the functions of the brain, decreasing the level of alertness and muscle coordination. It also replaces, or more like lowers the amount of alcohol or amount of oxygen going to your brain, and too much alcohol can cause you to have brain death. Short-term of drinking, it causes alertness and muscle coordination to be reduced, and that's why you should not be driving under the influence. Long-term effects of drinking. Heavy drinking over a long period of time, and I want to define heavy drinking. You're going to be very surprised. Okay, AA, Alcoholics Anonymous, defines more than 3 drinks in any one occasion as being heavy drinking. And if you are heavy drinking over, pardon me, if you're heavily drinking several days of the week, that's considered a long-term heavy drinker, and that's considered to be an alcoholic. The liver, which plays a major role of eliminating alcohol from the body, gets overworked. It gets stressed, and when it has to constantly remove this alcohol, it starts to build up levels of fat inside of it, and you get what's called fatty liver. You get this from other things too, such as eating the wrong foods and whatnot, but fatty liver is buildup of liver buildup of fat in the liver, and it can impede its function. The liver kind of is like a sponge. It's got a bunch of empty spaces on the inside where the blood flows through and gets cleaned. But when that fat builds up inside of it, then the empty spaces inside of it get clogged with fat, and it doesn't work very well. This is called cirrhosis. And cirrhosis of the liver is easily measured. We can tell postpartum somebody who has died. We can, as we do an autopsy, you can very quickly tell whether they drink. Excessive eating can also cause your body to be susceptible to cancer, brain damage, stroke, and lung infections. Once again, the occasional alcoholic drink, if done in moderation and done at the appropriate times, and not drinking and driving, is considered normal. Is considered something that we do. At a certain age, it's actually considered healthy to consume a very small amount of alcohol routinely. We're talking about 1 ounce of spirits, maybe 1 glass of wine on a daily basis. The American Heart Association says 1 glass of wine daily is very healthy for you, but just 1. You bump that up to 2 or 3, or you make them very large glasses, then all of a sudden you're drinking too much, and it can lead to very serious problems. So one thing that we're interested in when we do forensic studies is we're looking at the blood alcohol concentration. This is pretty easy. You basically draw some blood from the person, whether they're living or dead, and you put it into a machine that tests for every 100 milliliters of blood. We see how much alcohol is in that. So imagine this is 100 milliliters. That's not quite 100 milliliters, I don't think. But we then do test on how much of that is alcohol. If 0.50% of it, or 0.5 grams in that 100 milliliters, then you have a 0.5 blood alcohol level. The level of absorption may vary depending on the person. but as it comes out of the body constantly. You may be able to drink more because you're heavier, you may be able to drink more because you're bigger, you may be able to drink more because you're a male, etc., but everybody eliminates at the same rate. The kidneys and the liver pulls it all out at the same rate. So we can measure fairly accurately when you had your last drink. We can measure what you drank, how much you drank. It's pretty easy to determine all this. We might know that if we know that you have alcohol in your system, we can know that it might have interfered with the medication you were supposed to take. Lots of people go to the hospital because they're taking medication. Medication clearly says do not take with alcohol. They take with alcohol anyways. Then the next thing you know, they're in the emergency room, or they've died, and then we have to perform an autopsy. Most of the time, BAC tests are performed to determine whether the cause of accidents is driving under the influence of alcohol, but also murder scenes, accidental homicides, all of these things. It's nice to know, to talk to a jury, it's nice to know if there was alcohol involved. There's some pretty obvious ways that we measure blood alcohol. The best way is through breath analysis, little device cops carry it around with them. They give you a disposable plastic tube that we then insert into the side of the machine, and you're told to exhale. And then very quickly, this machine, this little device, can give you what is considered by the court to be a very accurate measure of the amount of alcohol in your blood at that time. Cops carry this with them in their car so that they want an immediate reading right then, as opposed to dragging you down to the station and having you do a blood test there. The whole time between the time you were arrested and taken to the station, your body has been metabolizing it and your BAC is going down. We want to know right then and there, have you been drinking, and if so, how much? It is considered to be highly accurate. There are some things. It is inexpensive, it's portable, and it doesn't involve drawing blood. It's very easy. There are some things that can throw it off. I read about a guy one time who was a fire breather, which means he would put a flammable fluid in his mouth and then kind of spit it out in front of a flame, and it would blow fire everywhere. It's actually very cool, but that gets all inside of the oral cavity in his mouth basically, and he was pulled over and given a breathalyzer test, and he blew something that was like 40 times over the legal limit. He should have been dead, but he was able to argue that he wasn't drinking, he had just had that stuff in his mouth. So sometimes it's inaccurate, but 99% of the time, and I mean more than 99% of the time, it's highly accurate. Another thing we can do is take a blood test. This is something that is expensive and you have to actually get injected by a needle, but it can give you an even more accurate, it's the most highly accurate form of alcohol test we have. And if you can get a blood test to show a jury, there's just really no arguing it. The blood this is how we literally are drawing your blood and then measuring the amount of alcohol in that blood. You can also do it as a urine test. It's not conclusive. It takes about 2 hours for alcohol to show up in the urine, so if you've been drinking, you might not even show in a urine analysis yet. Rarely do we use urine for measuring for the presence of alcohol, but of course it's quite common for measuring the presence of drugs, because drugs stick around in your body much longer than alcohol does. In the United States, it's illegal to drive with a blood alcohol level of 0.08 or higher. Most people begin to experience the effects of alcohol at about 0.02 to 0.06. They experience impaired judgment. When it's even 0.02 can start to impair you. When the BAC ranges from 0.06 to 0.10, the individual's reflexes are highly impaired. And I don't care who you are. I don't care what you say. I know that I have people who say, well, I can drink, therefore I'm fine. It's just simply not true. You're just being stupid. And so this is a situation in which you need to be responsible and not drive. Yes, if you're a heavy drinker, you build up a tolerance, and yes, you might find that you can drink a little more than another person and still not be impaired. But the problem is that most heavy drinkers don't just drink a little bit and drive. They drink a lot. That's why they're called heavy drinkers. And so typically that's why we set that level at 0.08, and if you go higher than that, I really don't care how much you argue that you're fine. I don't care how much you argue that you can get home safely. You're legally drunk. As an adult, I have an ability myself to go out to a restaurant and have a cocktail or a glass of wine or a beer, and I have done that on occasion. I've had one, but also ate my meal, and I knew that I was far below 0.08, and I had no impairment. And I'm also believe that this is a big problem, and I never want to be involved with any kind of car accident that might hurt or kill someone. So if I think I'm even close to feeling impaired, and this happens once like every 2 years, but even if I feel like I'm close to being impaired, I ask my wife to drive. Perfectly legal, perfectly acceptable. This is how people should do it, but they don't. And as a result, we have lots of automobile accidents that involve alcohol. And it should be brought up in court. If you are in a jury and you're listening to a guy who was arrested for manslaughter, and you're trying to determine his guilt or innocence, as the jury's job is, if there is evidence to suggest that this person was drinking at the time of the accident, that would have a tremendous effect on whether or not you thought they were guilty or not. So now we're going to talk about collecting blood. If you've never had blood drawn, it's a pretty straightforward situation. They don't use a needle that daggum big, good Lord. But they want to collect about 10 to 15 milliliters of blood for a blood sample. That's how much it takes to put it into the machine. And the machine then can tell us all kinds of things about the blood, one of which is there alcohol in it, or drugs, or other chemicals. Two types of blood collection. Ante-mortem, meaning mortem meaning dead, right? So ante, and if you are a Spanish speaker, this should be easy to understand because antes means before. So ante-mortem means before death, okay, which means they're not dead. You can collect blood from them, right? The other type is called post-mortem. Post means after, so after they died, you can still draw blood. There's a couple of places. We can get blood from the larger pools in the heart, the left or right chambers. There's a lot of blood there. We can stick a needle literally right into the heart and draw blood. That's a good. Blood starts to break down very quickly after someone dies, but the large pools of blood inside of these areas can still be liquid. You know how blood coagulates? Well, after you die, that's one of the first things that happens, is the blood coagulates. And on the peripheral, like all of your arms and legs and stuff, that happens very soon, and so it's hard to get blood from there. You can get it. It's called peripheral blood. It's reliable. You like peripheral blood because it's least likely to come in contamination with other body fluids, such as urine, snot, sweat, tears, or other things that were in the stomach. It's very reliable, and so that's one of the reasons we like peripheral blood. Central blood is nice because it probably gives us a better shot at looking at the toxicology. So there's reasons for getting both. Okay, so we get both. Not that big of a deal, but there are two types of blood. Once we get it, how do we preserve it? Well, we use a lot of chemicals. Sodium citrate is one. It prevents microorganisms and other enzymes from breaking down the blood, and it allows us to get the blood to a lab quicker. Mercuric chloride is another one. I would never inject these into me before I died, but if you draw a blood sample from a living or dead person and you want to preserve it, you can do it that way. If you want to prevent clotting, you put in potassium oxalate. It's preferred over blood thinners because these things like heparin, or I'm going to try it here, ethylene diamine tetracetic acid, can both thin the blood and keep it from clotting, but it also interferes with the chemical analysis. So we use potassium oxalate because it keeps the blood from coagulating, and it also doesn't interfere with the machine and the collection or the analyzation of the sample. We put them in these colored vials. The color helps to keep the sunlight from breaking them down. They're stored at low temperature, which keeps them, in a refrigerator basically, but a cold refrigerator. It's colder than one you have in your house, and it keeps them from breaking down even further. And of course, they're labeled correctly, and that label's got to have things like the case number, the subject's name, date and time of collection, and the person who collected it. All has to be on there. So collecting blood at a crime scene is something that a forensic scientist would do, and how to do it properly, how to preserve it, and then how to get it to the lab and analyzed in time before it breaks down is a science, and it's a tough thing. But and I'm sure that there are a lot of cases that have been lost because the defense attorney questions how quickly the blood samples got to the lab, and it could have had a problem. So one thing you got to do is do this right and do it quick, so that there is nothing for the defense attorney to make a case about. Okay, before I start talking about this last thing, I want you to know that I've skipped over in the tutorial several little assignments, and yeah, you have to do them. Just because I skipped over them doesn't mean you have to do them. It's just that on my screen they have the answers, and I don't want you to see the answers, so I skipped over it. But you have to do them. A lot of you guys are doing them very short. A lot of you guys are faking it. I get one student that just kind of bangs the keyboard and sends me garbled answers thinking that I don't grade them. I grade them. I send them back with a 0, or sometimes I'll send them back to you and ask you to fix them. But you got to do those things. They're part of a grade. I will not give you a good grade on this tutorial if you haven't completed them. So if you see a tutorial grade in the notebook or in the Skyward and it's low, it's because you didn't do the work. Okay, last thing is controlled substances. In addition to alcohol, forensic toxicologists, we also look for controlled substances. There's an act called the Controlled Substances Act. It categorizes pretty much everything into 5 schedules, Schedule 1 through 5. And if you are depending on what you're caught with, whether you're holding it on your person or whether you've ingested it, it has different results. Okay, we're going to look at all 5 under the Controlled Substances Act and talk about how they have they're different. Schedule 1 that's the worst one. If it's a Schedule 1 drug, it's stuff that it's got the maximum possibility for abuse, and these have no valid medical use. There's some discussion as to whether or not heroin and LSD could be used in very fringe situations to treat things. Certain people with certain psychoses have been treated with a very light amount of LSD, but these things have real detrimental effects, very little to no medical use, highly susceptible to abuse, and so they're considered Schedule 1. If you have one of these on your person, or if you have it inside of you, you are considered guilty of possession of a Schedule 1 drug. Schedule 2 is a little bit less. They do have some medical use, but they have to be severely limited. They have the high potential for abuse, which means that even though they're used, we want to limit it as much as possible. Physical dependence produces severe withdrawal symptoms, and so these are pretty rough, and includes things like morphine, methadone, and yes, even cocaine. Cocaine is considered a medical use. Depending on situations, you can have cocaine be used as an anesthetic in the right places. I've heard of it being used for broken noses, and I've heard dentists using it. It's hardly ever used, but medical grade cocaine is available, and doctors know when they're allowed to use it. But unless you have been given medical grade cocaine by a doctor, you are guilty of possession of a Schedule 2 drug. So again, that's what they are. Schedule 3, they've got less potential for abuse than 1 and 2. They do have an established medical use, but they are still highly addictive, and there's a very high chance of physiological dependence. It includes things like barbiturates, steroids, and ketamine, which is a painkiller. Schedule 4, they have wide medical use. They have a limited potential for abuse. People do get addicted to these. It includes things like Valium, Xanax, and tranquilizers. They're much more available. They're still illegal for you to possess unless you have a prescription. And finally, Schedule 5, these are the ones that have low potential for abuse. You can get abused to them, but they have low potential for abuse, and very low physical withdrawal symptoms. There's cough medicine that has something called codeine in it, and people can get addicted to it, but the recovery from it is fairly quick. And so these scheduled drugs are all addictive. It just depends on how addictive and how badly the withdrawal symptoms are. So that's what these are. And of course, toxicologists, forensic scientists need to be able to identify these drugs if they're found inside of a person, living or dead, or found at a crime scene. So we need to know what they are and then be able to identify them. So how do we identify drugs? Well, we collect them either in body tissue samples, or just like we talked about before, collecting stuff at a scene. You collect stuff at a crime scene, a suspicious powder in the carpet, some crystals sitting on a table, and you want to know, is this drugs or is this just something else, right? So a couple of things. Right at the scene, we can do what's called a presumptive test. They establish that yes, this is possibly drugs, and you just put a chemical on it, and the chemical changes color, and you're like, well, that looks like cocaine to me. That's the reason. So then you send more off to a lab, and then it comes back positive. You want to do presumptive tests like the microcrystalline test at the site if you can, because it can help. That information immediately can help other investigators, detectives, determine things about the crime. And it also lets you know whether or not you should send this substance off to the lab for more testing. If you sent every single substance that you found off to a lab, you would be sending thousands. It would cost thousands and thousands of dollars to get it tested. And so if you can do a quicker test at the crime scene to get rid of it, like the color test, the spectroscopy, and the thin layer chromatography. These two don't necessarily get done at the crime scene, but they're done very quickly back at just about any lab. Then you can avoid spending an expensive amount of money on the next type of test, which is a confirmatory test. The confirmatory tests involve things like gas chromatographs and mass spectroscopy. And essentially all that these things do, the gas chromatograph is really cool. They're heated. Some substance, we don't know what it is, it's heated until it turns into a gas. That gas is then put into a very tall column, and the heavy parts of the gas sink to the bottom, the light part of the gas float to the top, and then it's slowly passed through, so it's slowly pushed out, and a light beam can measure the literal molecular weight of the gases being passed through there. And as a result, we then can compare it to what we know is already, like if we know that cocaine does this in a gas chromatograph, when we get the sample, if it does the same thing, well then our sample must be cocaine. So that's how a gas chromatograph is used. The other one is called mass spectroscopy. It uses light in a water solution. It's very similar. The gas chromatograph is considered to be like a benchmark standard. When you have gas chromatograph evidence in a crime, you've got something that's hard to argue with. So that's it. Quick review. We talked about alcohol, how alcohol works, how it works in the blood. We talked about collecting blood samples and the best way to do that and preserve it, and a little bit about the rules and a little bit about the importance of collecting it properly. Then we talked about drugs and how we collect and test for drugs. Pretty quick, pretty easy chapter. So I'm going to end it right here. Go back through this, take the notes, look at the supplemental material I will add in there shortly, and finally take that mastery test. If you didn't do well in the mastery test, restudy your notes and take it again. All right, that's it for this week. I will see you next week. Bye.